Okay. Sige, may hapon po, no? Salamat sa feedback. Anyway, for this session class, our main agenda would be on discussion sa ato ang quiz number 2 and then continuation no, sa ato ang discussion on equilibrium of force systems. So last time we had equilibrium of force systems, specifically concurrent and non-concurrent force systems, right? So this time, let us also discuss equilibrium of force systems applied on parallel force system. Okay? And it will be the last topic nga included no sa to midterm examination. In fact, ang coverage sa to midterm examination is from topic number 1 no, so from the very beginning nga discussion nato until sa to ang i-discuss sa ato ang i-discuss today. Okay? So first, i-discuss lang sa nato inyong assignment. I know not assignment but quiz number 2 rather. So um I have prepared here a solution manual for quiz number 2, which means that dili na to siya i-solve or dili na ko siya i-solve manually, no? So, i-run through lang kibalita mo sa ato ang solutions. Okay, para dili na pud kaayo ta mag-take time. Sige, so we have here our quiz number 2. So, situation 1, kuan lang ni siya class, bonus ra gyud ni siya sa inyo, no? So, this is worth 5 points. Di ba? So, you are just asked about the force. No? So, how much force rather, no, which must be applied to the wheel if the valve can be opened with a couple moment of 50 newtons meter. So, we know that couple is just equal to force times distance. No? Muna yung formula. So, couple there is a moment. And we know that a couple is composed of two forces oppositely directed but equal in magnitude. So, therefore, ang ipangita sa problem class is kani siya si F. Okay? So, distance, so that is just the distance, no? Separated by, I mean, the distance between the line of actions of your force, no? Couple forces. So meaning distance there is 400 millimeters. And since moment is in terms of Newton meters, so we must also convert this one in terms of meters. So 400 millimeters in terms of meters is 0.4, di ba? 0.40 or 0.4 meters. So that is why you have there 0.40. So substituting that one into our equation for couple moments or couple 50 is equals to force times 0.40. So dividing both side by 0.40, you'll obtain the force. No? Force is equal to 125 newtons. So, di ba, easy lang siya. Next problem is this one. So, a rigid structure is loaded with the three forces and a moment at point B. So this is actually on non-concurrent nga force system class, no? Kay you have there a combination, no? Kay namatay parallel force and then apud tayo inclined force, no? So this is an application of non-concurrent nga force system. So determine the resultant force of the given system. Resultant force, kung saan ito pag-solve, diba R is just equal to the square root of Rx squared plus Ry squared. Okay? So we must determine the total force acting on x-axis and the total force acting on y-axis. Okay? So ina na lang ba yung atong pag-determine sa resultant force? So how much is the total force nag-act sa nga system? So with that, no, so we just have to sum up forces on x and y axis. So first, summation of forces on x axis. You have here Rx is equal to summation of forces along x axis. What are the forces acting on x axis? Kinsa man. It's just the x component of this 15 Newton na force. Okay? So since we have an inclined load here, si 15 newtons, so if ato na siyang i-resolve into x and y components, therefore na atay force mo nag-act sa x-axis. Okay? So, um, again, no, if nagatay mga inclined loads, so much better or it is easier for us or much convenient for us. Nga i-resolve na to na siya into components and then we'll just have to sum up forces no along x and y axis no for both components to eventually compute for the resultant force. Okay? So, siya raman no ang naa sa x-axis or siya ra nga force ang nag-act sa x-axis. Wala na may lain, wala tayo laing makita because kani si 5 newtons, 10 newtons, and kaning y component of 15 newtons is they are acting on y-axis naman. So other than that, si kanilang x component of 15 newtons ay nag-act sa x-axis. So with that, no, so 15 times 3 over 5. Kaya gitagaan mo tao similar triangle class. So you have the hypotenuse 4 and 3, no? 4 as the altitude of your triangle and then 3 ang base sa imong triangle. Now, pwede nga kuhaan mo ni siya og angle, no? Angle theta. Pwede nimo i-solve si angle theta. So how to compute for the angle theta? So um, you can use all or you can use either of the available nga trigonometric functions no from SOHCAHTOA because given man ang sides. So tangent function possible makuha si angle theta. Sine and cosine function makuha gyapon nimo ang angle theta. So after nimo makuha ang angle theta, then compute for the x component no of 15 newtons. Pwede po na siya nga solution. Okay? So no problem with that. You can try that one later siguro after sa tuang online class no para mas ma-discover ninyo, mas ma-explore ninyo ang mga possibilities nga pwede siya nga solution. Okay? Regardless, we will still obtain the same answer no which is Rx is equal to 9 newtons. So kami siya is remember last time 'di ba? This is just the shortcut. Instead nga kaon pa nato ang angle theta, pwede na nato gamiton ang relationship mismo no sa to ang sine, cosine and tangent function. Okay? So 15 3 over 5. So 3 since we are after the x component no over 5 as the hypotenuse. So Rx therefore is equal to 9 newtons. Ry, so summation of forces on y-axis punta. So what are the forces on y-axis? You have 10 newtons, so negative since downward direction, plus 5 newtons since upward direction man see 5 newtons, minus the y component of your 15 newtons. And that is just 15 multiplied by 4 over 5. No? So we are after the y component. Okay, so solving for this expression, we'll have Ry is equal to negative 17 newtons. So nanatay Rx and Ry. Finally, we can compute for our resultant force R. So R therefore is just equal to Rx squared plus Ry squared. So substitute the values for Ry and Rx. We will obtain the resultant force is equal to 19.235 newtons. Okay? So, I hope nasabtan na naka-follow na ha kay basic lang kay na siya class. So, I hope nga nakuha ninyo ni siya sa inyong quiz. So, resultant force therefore is equal to 19.235 newtons. Okay? So, if atong i-plot no ang ato ang components of our resultant force, Rx is positive, therefore we know that to the right no or acting right side iyahang direction siyang force. Then Ry is negative, so downward iyahang direction. Right? So, we know nga ang ato ang resultant force are naa siya na nag-lie no between and I mean not between but naa siya sa fourth quadrant nag-act no so inani iyang convention or iyang direction. So nanatay initial assumption sa itsura sa ato ang resultant force. So moving on with the next question, no, with the same problem lang, it's just that lahi ang gipangita, no, the angle of inclination, no, this time angle of inclination na of the resultant force with respect to the horizontal beam AB. So kaning angle theta ang gipangita class. So as mentioned ako earlier, di ba nga naa siya sa fourth quadrant nag-act. So we know nga inani iyang itsura. So kung ato na siyang i-plot diri sa to ang figure. So assuming na siya diri nag-act, no? So kaning angle theta ang gipangita. Okay, kana siya. So by the way, no, um dali ra kayo ninyo makuha ang angle theta because ato lang gamiton or we'll just take advantage of the components of our resultant force R. Di ba na-solve naman nato si Rx and si Ry? So if i-plot nato sila, we'll have this um, lines of actions no of our forces. So out of that, kung applyan nato na siya og, triangle law, no? From our previous discussions or sa ato ang mga basic fundamentals sa ato sa statics, um, maka-create ta og right triangle. So with this, ang kaning angle theta no is just equal to this angle theta here because it is just with respect to the horizontal man, no? Horizontal axis. And your beam AB is along horizontal axis. So therefore, Ry is the opposite side of our angle theta. Rx is the adjacent side of our angle theta. So with that, tangent function atong gamiton, no? From SOHCAHTOA, TOA, so tangent theta is equal to opposite over adjacent. So opposite is Ry, adjacent is Rx. So substitute the values for Ry and Rx, you'll obtain theta is equal to 62.103 degrees. Okay? So ana lang siya. See, dali ra kaayo siya class, no? So, next is situation 4. A rigid beam is loaded. Okay, the same lang siya gyapon nga problem, no? It's just that lahi na sa niya. Lahi na po ang gipangita sa problem. It is now the distance between the distance from point A to the point of interception of the resultant force through the beam. So, isa pasabot sa to ang point of interception, no? So, it only means the point of intersection na kung asa nag-intersect ang imong resultant force kang beam AB. So, in short, amo ni siya class, oh. Di ba, dari man sila nag-intersect? So, muna siya ang point of interception. So, the problem ask us to determine kung unsa na siya kalayo no kanang point of intersection sa imong resultant force along AB. So from point A padulong ana nga point, I label that one as distance x, no? So we must find x, di ba? We must find x, y. So now how do we find this distance x? So of course, we'll just have to apply the Varignon's theorem. So ayaw yun yun kalimiti ang Varignon's theorem class. Importante kini siya nga principle diri sa engineering mechanics. Okay? So Varignon's theorem is not only limited to distances, but it can also be applied on areas, etc. etc. No? Pwede na to siya gamiton, no? Kung lagated ang mga areas, mga sub-areas, then one whole area, dayon you wish to locate no its centroid, so pwede na to na siya gamitan on Varignon's theorem. So sige lang, later on we'll arrive there. Okay, so for now let's just utilize Varignon's theorem no, to compute for distances. So as you notice or if you observe from our previous nga mga discussions, we've been using this theorem, Varignon's theorem, to locate, di ba, to locate the point of action of our forces. So with this no, by applying Varignon's theorem, makompute na to ato ang distance x. So, how do we do that? So, take note class, kani siya is, so from Varignon's theorem, di ba? Resultant ni siya. So, summation of forces, not forces, but summation of moment at point A with respect to the resultant force R is equal to the summation of forces or summation of moment rather, summation of moment with respect to its components of the whole system. Okay? So, ingon ana siya. So, this one is, di ba, summation of force times distance. Force times distance is just moment. Basic equation of moment is force times perpendicular distance. Di ba? So, kani po siya nga components class na napasabot, dili ni siya component sa imong resultant force alone. It is the component of force system. So, kinsa man na sila. So, muna silang 5, 10, 15, no? Muna sila mga components. Kani po si moment nga 45 Newton meters. Okay? So, kani siya si resultant, mag-sum up to of forces, moment at point A with respect to this resultant force. No? So, si resultant force ato ang basihan. Now, naka-inclined ang ato ang resultant force R. Di ba? Na siya angle of inclination, which is ato siya na-solve kaganina. So, when we take moment at point A, so we must determine the perpendicular distance. Kani siya, di ba? So, saan man na siya pagpangita? Maglisod ta, di ba? So, kung anong i-complicate na itong life, kung na ay easier nga method, no? So, what do we do? Ato na siyang i-resolve into components, right? So, na siya RY and RX. So, another problem is, pila may perpendicular distance, no? Kani sila. So, pila man ni siya, no? So, um, now, dali na mosulod no ato ang principle of transmissibility. Okay? So if you recall from our previous discussion, kani si principle of transmissibility, unsa gyud na siya pasabot, it only states that along the line of action of your force, equal lang ang imuhang magnitude no of your force. So meaning kung i-resolve ta ning resultant force at this point no of your line of action sa imong force, equal lang po na siya no kung i-resolve ta na siya diri nga point. And so on and so forth, no, the ring apart. Now, ato na siya i-plaster, no, wherein strategic ang location. So, asa man na nato ibutang. So, of course, dito ta sa point of interception, the ring apart, no, the ring a point rather. Okay? So, nganong dana man nato siya ibutang? That is because um, when taking moment at point A, si RY, no, is just our distance x. So, no problem with distance x, no, or moment arm of ry. Since mo man itong goal, mo nang ginapangita sa problem, di ba? So, rx pod, no, x component of your resultant force. So, when taking moment at point A, mag-cancel out siya, di ba? Kuan lang na siya, ma-eliminate lang na siya. Okay? So, ano mag-eliminate man na siya, class? Sige. Anyone? Napamudi class?
Yes, sir.
Oh, sige. Nganong man kung mag-moment na kang point A, nganong mag-cancel out man si RX, nganong dili mo siya ma-consider sa atong analysis. Anyone? Sige lang, ay, kahit i-share. Balag. Kuan. Di siya perpendicular. Um, another, partly
Quad siya, sir, along the X quad siya, X component.
along X component. Okay, so, hapit na, no? Murag, ni Kay lang. Although, okay, no, so I appreciate no your participation. Yeah, it's actually correct no nga. Along siya pero dili siya sa x-axis. Along siya sa line ang iyahang line of action of your RX is along point A, di ba? So, di ba from principle of moment, moment is just equal to force times distance. So it must have distance no or perpendicular distance. So that is why ningon po ko ganina nga di siya perpendicular na nag-answer ka ganina na so partly correct technically. But technically, mag-cancel out na siya because ang iyang line of action class is nag-act siya kang point A, no? Along point A. Okay, so muagi siya kang point A. Okay, so ayun na niya siya og kalimti class. That is why, kung mag-take tag moment kang point A, mag-cancel out si RX. No? Hindi siya ma-appeal sa ito ang analysis. So, with this, wala na tayo problema ho, no, nga moment arm ni RX. Kaya ma-eliminate man siya. So, see, very convenient no kung sa point of intersection na to siya ibutang. Applyan og principle of transmissibility and then resolve na to siya into X and Y components. So with this, no, let us now formulate our equation using Varigman's theorem. So summation of moment at point A with respect to the resultant force R. So since ang resultant force R na to is up to mo na siyang dibagi resolve into components Rx and Ry, therefore si R and Rx and si Ry ang ato ang basihan sa to ang pag-take og moment at point A. So, considering or assuming counterclockwise as positive. Okay? So, we have here Ry. So, with respect to point A, unsa man nga rotation nga ma-create, it is clockwise, di ba? So, clockwise rotation and since clockwise man na siya, And I assume counterclockwise as positive, so negative, no? Negative Ry multiplied by moment arm nga si X. Mo man niya ang moment arm, di ba, ni Ry. Padulong kang A. So, wala na ilain, no? Kasi si Rx is mag-cancel out lang man siya. So, equal now to the summation of moment at point A with respect to the components of the forces of this whole system. Okay? And what are those? You have 10 newtons. So, with respect to point A, 10 newtons will tend to rotate clockwise rather, no? Clockwise gihapon. Okay? So minus. So negative rather. No? Negative 10 times 4. So 4 meters man yung moment arm. Plus, so nag-positive taan ano or nag-plus taan ng 5 newtons because 5 newtons will tend to have counterclockwise rotation with respect to point A. Moment arm is 6 meters, no? 4 plus 2. And then, kaning inclined force class. So kung mag-take tag moment at point A, di ba, ingon ta na dapat perpendicular siya sa imong line of action sa imong force. So kung mag-take tag moment at point A, meaning kani dapat nga force, no, or rather not force, but kani dapat ka distance atong pangitaon. So kung maglisod taan na, again, ato lang na pwede siya i-resolve into x and y components. So, si y component, walay problema, no? Makita na nato dire sa iyang moment arm. And that is just 8 meters, no? 4 plus 2 plus 2. So how about iyang x component? So similar with the resultant force R ng x component, mag-cancel out lang po na siya, no? Kung mag-take tag moment at point A. So since its line of action is acting along point A, mag-cancel out lang na siya. Okay? Ma-eliminate siya. So, which means, sa kaning 15 Newton na force, ang kaning Fy lang, no, or iyang Y component lang ang naay effect sa moment sa point A. And that is um, Y component, no? So, 15 times 4 over 5. 4 over 5, yeah. So, 15 times 4 over 5 times 8, no? As mentioned, moment arm is 8. So minus, since the y component of your 15 newtons will tend to have clockwise rotation as well with respect to point A. Okay? Now, take note class nga naa time moment, no, applied moment at point B. So na ay 45 Newton meters. And we are taking moments, di ba? Summation of all the moments in your whole system. That is why ma-include na siya sa imong analysis. So if you notice, counterclockwise yung rotation and assumption na ko is counterclockwise is positive, that's why nag-plus ta of 45 there, no, sa atong equation. Okay? So dili na nimo siya i-multiply by its distance, no? Basi maglibog mo ba nga i-multiply pa na nimo siya sa distance 45 times pila man ang total. 13, no? No, 11 rather, no? So 11 meters ang iyang total length. So you might be confused nga i-multiply pa nato siya sa iyang distance. So dili na natin mo siya i-multiply sa distance class because this is not a force, no? It is a moment. No, it is a rotation. Apply siya nga moment at point B. Okay? So um we need to ato lang na siyang i-add or i-subtract sa to ang equation automatically, no? Depende sa iyang rotation. So in this case, counterclockwise man siya, so positive, no? So gi-plus nato siya, plus 5. But if ever nga mag clockwise rotation na siya there, so that's the time na mag-minus wag ka na rin, minus 45. Okay? So ana siya ha. So I hope nga na nasabtan na siya. So again ha, dili na natin mo siya i-multiply by its distance, no, or moment arm. So solving for this expression or equation, so substitute Ry, pila galito atong Ry? 17 newtons, right? You have there 17 newtons. So the negative sign there only indicates the direction. Okay, but the magnitude is 17 newtons. So with this, solving for x, makompute na to si x, which is equal to 3.588 meters. Alright. So, therefore, kung ato siya tanawon, no, kung point A, padulong kang 10 newtons na force is 4 meters na, Nara day dapat diri mag-aksi resultant force are, no? So the true location of your resultant force is naa din nga part somewhere here. Okay? So inga na siya pa-interpret sa to ang answer. Anyway, it's just the same, no? So assumption naman po noon siya nga location. So after calculation and investigation, so we found out that the point of interception of your resultant force lies at 3.588 meters from point A. Okay, so that's it. So this is now our answer, no, for situation 4. Okay, so I think for this certain situation or scenario, mora ni to ang last na question. So let's proceed with another na problem, no, another na figure. So situation 5. Kani siya nga problem class, no, ako ani siyang gi-exclude sa inyong quiz number 2. Okay, ako na siyang gi-exclude because ang ako ang na-set dito nga answer class is in SI unit. No, naa siya sa SI system of unit. However, ang akong nahatag sa inyo nga figure is naka-fit ni siya, di ba? Naka-fit. So, no problem if kung kani nga to ang quiz number 2 kung nag-handwritten solution ta ani, um, akong i-accept no inyong answer if inyong final answer is SI unit or in English system of unit. So, no problem with that. Ako ya po na siyang i-accept because in the first place, wala man nag-indicate ang problem kung unsa nga unit i-express ang final answer. Okay? So, sa use that side, you don't have an idea kung unsay correct answer nga nabutang dito, no? So, ang akong na-set actually nga correct answer sa use step is naka-SI unit siya. So, it would be unfair man pud kaayo nga kaning nag-answer mo sa English tapos correct inyo nakuha ang value 40 but ang naset nako is SI. So I have decided nga i-exclude na lang nako din siya, no, but although i-exclude na ko siya, ato siyang i-discuss today, no, apilon nga po nato siya o discuss. Okay. So if ever class maka-encounter mo ani nga problem, no, nga wala na coincide ang imuhang units kay ato ang mass is in terms of kilograms, no, naka-SI siya and your distances is naka-feet na siya sa US customary units. So ang inyong buhaton lang anak class is kung unsa tong majority nga units, consider it as your unit for your final answer. So either or it is much convenient for us man po di ba nga ang mass ato na siyang i-convert into pounds, di ba? So with this uniform na ato ang not uniform but in one system na ang ato ang units. Naka-English system of unit na siya. Or pwede sad na ang kaning katong mga naka-feet, no, i-convert niya siya into meters kay para magamit niya si 80 kilograms nga naa sa SI. Okay, so both ways are actually correct. It's just that sa use step lagi is SI lang ako ang na-set nga correct answer, no. Kaya nga ako ang um, solution manual, which is kaning solution manual ako niyo, no, kay mao ni akong nabasihan ng mga distances and lahi ang akong na-set pod sa use step. So, sige lang. Anyway, sa board exam, di pa naman problema kay naka-multiple choice man na siya, no? So, let's say A, B, C, D. You will have an idea kung unsa nga unit ang final answer. Like, for example, this is 10 kilonewton, 100 kilonewton, etc. etc. Kung naka-kilonewtons na sila, miskin pa og ang imuhang mga given parameters naka-feet, naka-inches, naka-pounds. So you have an idea nga you need to convert these no into SI system of unit kay naka SI man ang final answers sa imong choices, di ba? So multiple choice actually ang board exam class. So di ra mo mag-worry, no, di ra mo um, mabala ka nga unsa nga unit ako express ako final answer if ever maka-encounter mo og inani nga problem, no, naka SI at naka English unit, no. So anyway, going back to this um, problem, no? Uy, na-exit. Okay. So you have here pulley at D rather, is frictionless. And the cylinder has a mass of 80 kilograms. Take note, mass ang gihatag no, of the cylinder. So this is our cylinder no, muna siya. So we need to compute for its weight first, no? So weight is just equal to mass times gravity. So therefore weight is equal to 784.8 newtons. So no problem with weight, na natay weight dire. So um ano class no? At D, no, this pulley daw kono is frictionless, which means that this one rope, no, kaning isa naman ni siya ka rope, the same lang na iyang ka-experience nga tension, no? The same lang na nga reaction iyang ka-experience all throughout along sa iyang length, no? All throughout its length. What man? Okay, so sorry for the interruption, no? So going back to our discussion class, um, again, um, kani siya ng marup, no? Kay the same lang na ihangga ka-experience nga reaction, which means that your tension here at B is just equal to your tension also here, no, at this point. Okay? So, gilabel lang na ko na siya as T. So, if I want of free body diagram, ani niya, no? So, muna ni siya to ang mga exposed ng mga forces and reactions. And also, at point A, from our previous discussion or our discussion on equilibrium of four systems, ako man na siyang gi-introduce diba sa inyo ha, that kani siya nga type of support is a hinge support or pin. Okay? So meaning, if pin or hinge support gani siya, naana siya duha ka reactions. Alright? So naana siya horizontal and vertical na mga reactions. So as you can see here, AX and AY. Okay? So muna yung reactions. Okay? So now, unsa to gipangita sa problem T, no? Si tension T. So how do we find T? So you might be thinking mag-sum up the forces on y-axis equal to 0. So this is actually an application on equilibrium of force system class. Okay? So if kanya tong buhaton class, walay problema si W since na-obtain naman siya. And also W is acting along y-axis. P is unknown and also AY is unknown. We don't know the reaction at AY pa. So, if magamit ani summation of forces on y-axis, we have two unknowns. So, we cannot directly compute either of these unknowns. Okay? So, meaning, proceed sa tanong with the third equation for equilibrium, which is the summation of moment equal to 0. Okay? So asa man ta pwede mag-moment? Ako na siyang gi-discuss last time also nga basta gali hinge or pin support, they don't have resistance to moment, no? Wala na sila resistance to moment. And therefore, we can say na at moment at point A is equal to 0. No? So pwede na to siya applyan o equilibrium nga equation. So makasum up the moment at point A equal to 0. Okay? So with that, muna siya itong buhaton dere. So summation of moment at point A equal to 0, having counterclockwise as positive. So automatically AX and AY will be eliminated. No? Kaya nag-moment mat at point A, and these reactions are acting directly at point A. That is why ma-eliminate siya sa atong analysis, which means it leaves us with T na lang nga unknown variable no sa whole system. So kung mag-moment at A, ang makuha nato is ang T. Okay? So also kaning incline nga T no, mura niya to ang basihan. So gitagaan ta og slope which is 2 ang height then 1 ang base. Okay. So gitagaan man tag slope no, 2 ang height, 1 ang base. So kung i-compute na to na iyahang hypotenuse. So it's just unsa man. So from Pythagorean theorem, 2 squared plus 1 squared. So 4 plus 1, no? So square root of 5. That's why you have there square root of 5. Okay? Inanaan na siya pagkuha. So kung mag-sum up ta og moment at point A, so again na maglisod na kung kaning perpendicular distance atong pangitaon ni T. That is why mas convenient if ato ni siya i-resolve no into its component. So you have ty and tx no for this inclined t. Okay? So galihok for a while. Okay. You have here summation of moment at point A. So from kaning W no weight. So weight of your cylinder will produce unsa nga rotation with respect to point A that is clockwise. So negative W times 4 since 1.5 plus 1.5 is 3 plus 1 so 4 meters. 4 meters is the moment arm of your weight na force, no? Negative since counterclockwise nato is positive ato ang assumption. Next, plus kaning y component no of t. And with respect to point A, counterclockwise yung ma-create nga rotation which means positive, no? So plus atong operation plus t times 2 over square root of 5 times 3, no? 3 iyahang moment arm since 1.5 plus 1.5 lang na siya. Okay? So kani siya class, this is just, unsa man na siya? T times 2 over square root of 5. Okay, so again, pwede po nga kung ano mo na siya og angle theta. Then express ty no as a function of t. So kuhaan mo siya og y component si t. Okay? So pwede po na siya. So continuation. So tx is ma-eliminate siya, di ba? Kay mag-acram niya po na siya along point A. So next is kanina po siya nga t, no? So t times 1.5 lang and positive since counterclockwise ang yung ma-create nga rotation. So basically this is ty. Okay? Equal now to 0 since sila naman ang nag-act sa system. Solving for t, therefore t na to is equal to 750.416 newtons. Okay? So we have solved for tension already, not t. So next is determine the horizontal component of reaction at pin A, and then the other one is the vertical component. No, the same problem, it's just that horizontal and vertical component na ipangita. So horizontal component muna siya si AX. Alright? So muna siya si AX no, yung pasagot. So atong buhaton ani, we'll just have to sum up forces along x-axis. And what are the forces along x-axis? So it's only AX and the x component of force T. So you have diba Ty and Tx. So Tx is to the left, that's why nag-minus ta diri. Then Ax is to the right, so positive ato ang convention. So T, ato naman siyang na-solve, which is 750.416 multiply by 1 over square root of 5, masolve ra gyapon nato si Ax, di ba? So Ax is just equal to 335.596 newtons. Okay, so this is the correct answer no of our situation 6 nga problem. Next is iyahang vertical component. Vertical component is AY, no? So note that the assumed direction of AY is upward. Okay? So let's just sum up forces along y-axis. So by applying the equation of equilibrium, summation of forces along y-axis is equal to zero, having an upward direction as positive. So upward man ang ato ang assumed direction ni AY. So positive sign convention. AY plus T plus kani siya is the y component. Okay? The y component of your uh, inclined T minus W. Okay, then substitute the values for T and W. Isa na lang din itong unknown variable, which is ang AY. Alright? And then solving for that, we will obtain AY is equal to negative 636.808 newtons. Okay? So, the negative sign there, class, indicates that the correct direction of your AY is opposite to the assumed direction. Okay? So, the assumed direction is upward, meaning ang correct niya nga direction class no ni AY is downward dapat na siya. Okay? That is why I have indicated here or I have put here through AY, no? Through nga direction of AY. Downward siya. Alright. So, that's it lang, no? For the equation of equilibriums class, equations of equilibrium rather. So next, no, this is actually the last problem, no. But duha ka buk ang duha ni siya ka items sa inyong quiz. So the first is compute the force in the cable, and then the other is the same problem but the total force na acting on at pin A. Okay. So sige. We have here a complicated looking na problem, no? Kay ano triangle naman ni siya, naghiwi na ang boom. Then napay cable, no? So, gipangita sa problem first is, di ba, the force in the cable, no? So, we know that the cable is tension na iyahang reaction. So, we have here T. So, kung magbuhatag free body diagram, we'll have this one, no? Kung magkata diri, ma-expose ang reaction sa imuhang cable, so it will have tension, no? Tensile. So, sige. Again, T ang gipangita sa problem. And take note, no? Note that this is a hinge support or pin support, right? So kabalata nga na siya duha ka reaction. Okay? So this one if di mo na siya si pin A, no? So the horizontal reaction of A, so ako siya pangalan as AX, and the vertical reaction of A, ako siyang pangalan as AY. So we don't know AX and AY yet. That is why if i-apply na to ang atong equations of equilibrium wherein summation of forces along X and Y axis is equal to zero, dili na to makuha directly ang either of the unknown variables because unknown ang AX, unknown si TX. So wala tayong makuha no along X-axis. Kung AY pod, unknown si AY, unknown also si TY. Right? So, summation of forces along X and Y axis is expression lang no, or equation lang ang ato ang makuha. But if mag-take tag moment at a certain point, then that's the time no, na natay makuha nga unknown variable. Asa man ta na mag-take og moment. So again, at the hinge support. Okay? Since hinge supports do not have resistance to moment, therefore, moment there is just equal to zero. Okay? So, kung mag-moment at point A, ma-eliminate na po si AX and si AY. And that leaves us with T na lang nga unknown, no? Si TX and si TY. Okay? So, um, if mag-take ng moment at point A, considering T, so kani dapat ito ang perpendicular distance na pangitaon, di ba? So, unsa man na to pag-compute yung perpendicular distance? Maglisod ta, di ba? That is why ato na po ni siya i-resolve into components. Okay? So, you have Ty and Tx there. Kay para, ang problema ko lang is kani nga distansya. Kani siya nga distance and kani siya nga distance here. Okay? So, this distance, ako na siyang gilabel as A, and also, kani siya nga distance is gilabel na ko na siya as B. So, as you can see, pwede na to na siya buhatan og relationship, no? So, applyan na to siya og trigonometry nga relationship, no? From trigonometry, maka-create lagi ta og right triangle. 'Di ba? So, um, this distance here, kani si A, will serve as the altitude of your right triangle, while B will serve as the base of your right triangle. And the length of the boom is the hypotenuse, no, of your right triangle. So you have here a representation of it. No? So 2.5 ang hypotenuse, A ang altitude, B ang base. So with this, no, ang angle of inclination is 30 degrees man daw. So natay angle na pud tay hypotenuse. So from Sohcahtoa, pwede na to mas-solve ang A and B. No, so A is the opposite side of angle 30 degrees. Therefore, from Sohcahtoa, sine function atong gamiton. So, no, sine theta is equal to opposite over hypotenuse. That is why sine 30 is equal to A over 2.5. Therefore, A is 1.25 meters. How about B? B is the adjacent side of our 30 degrees. That is why from Sohcahtoa again nga principle, no? So, we will use cosine function. So cosine 30 is equal to adjacent, which is si B, all over the hypotenuse na si 2.5. So B therefore is 2.165 meters. So kung moment at A, no problem with the moment arm of Tx and Ty. Okay? So how about kaning duha ka vertical loads nga applied, no? Kay ayon yung kalimti. Kay ana ba sa problem? The boom supports two vertical loads. So kaning two vertical loads refers to this 350 newtons duha ka buok, no, acting at D and B. Diba? So, kaning 350 newtons nga nag-act at B, so no problem. Kaya iyang moment arm is kanilang yapon, small letter B. How about kaning nag-act kang letter at point B rather, no? Nga 350 newtons. So, wala na to na-establish yung distance. So, let us solve for it, no? So, ako siyang i-label as small letter C. So, applying no the relationship of trigonometry also, so maka-create og another right triangle, smaller right triangle. The angle of inclination is 30 degrees and ang hypotenuse is 1.5 meters na lang. Kanina lang siya, di ba? So, C, no, kani siya nga distance, kanang C, is the adjacent of our angle 30 degrees. Meaning, from Sohcahtoa, cosine function atong gamiton. So, cosine of 30 is equal to C over 1.5, and that gives C equal to 1.299 meters. Okay? So, it is important first to establish distances. Okay, para later on, diretso-diretso na ang muhang pag-solve. Okay? So, proceeding no by taking moment at point A equal to 0, having counterclockwise as positive, we will obtain T eventually. Okay? So, you have here negative 350 times 1.299. So, kanina siya nga 350, no? Because, kanina siya nga 350 with respect to point A will cause unsa man nga rotation that is clockwise, right? And we assume, or I assumed, counterclockwise as positive. That's why negative na siya there. Negative 350 times iyang moment arm, which is si C. So, 1.299. Next expression or next term, you have another minus 350 times 2.165. So, mo na siya nga 350. So, moment arm, so si B lang, no, small letter B. And that is 2.165. Minus, since it will also create clockwise rotation with respect to point A. Okay? Next, isa pa may force. You have Tx and Ty, no? So, Tx with respect to point A will cause counterclockwise na rotation, right? That's why plus ato ang Tx here, not plus Tx times moment arm of Tx is small letter A, which is 1.25. So you have there Tx times 1.25 plus, so plus ta, so expect na nga counterclockwise ang rotation sa tong Ty, right? And it is counterclockwise indeed, no? So with respect to point A, Ty will create or will rotate counterclockwise. Okay? So, moment arm of Ty is, pila man na siya, sa small letter b. So, that is 2.165. That's why you have there plus Ty times 2.165 equal now to 0 since they are just the forces acting on the system. Diba? So, now, considering this first equation, no, wala tayong ma-solve directly because we have tx and ty, no? Duha ka unknown variable. But we can actually express tx and ty as a function of t, 'di ba? Pwede man nato na siya kuhaan og x and y component. So, ty, the y component is just equal to t times 3 over 5. And tx, the x component is just equal to t times 4 over 5. So, substituting that one here, tx and ty, so we'll have one unknown variable na lang, 'di ba? Which is si t. Okay? Ano na lang. Okay? So, with this, no, with this equation, masolve na to direct si t. Solve na to siya directly, no? T therefore is just equal to 527.360 newtons. So, that's it, no? For this. Okay? So, last item, no, for our quiz is this one. Igipangita is compute the total force acting at pin A. Okay, so sa may pasabot ni total force. So, total force class no refers to the resultant force at pin A. So, I'd like to rephrase this one or ilisan ako siya term, but resultant reaction. Okay, resultant reaction at pin A rather. Okay? So kung mayroon taog resultant reaction at pin A, unsa man ganito pag solve ang reaction, di ba? It's just the resultant force is just equal to the square root of Rx squared plus Ry squared. So in this case, Ax and Ay, so si force A atong gipangita, no total force of total reaction at A. So in this case, Ax squared plus Ay squared. Okay? So this total force refers to A. Okay? So ingana siya class ha. Not the total force ani nga system, no? Not the resultant force of this system. The resultant force of the reaction no at A. Kani lang siya. So we must determine AX and AY, 'di ba? To solve for the total force. Sige, so how do we determine AX and AY? So first is AY, no? Solving for AY. So the assumed direction of AY is downward, no? The assumed direction of AY is downward yung reaction. So by applying the equation of equilibrium, summation of forces along y-axis is equal to 0, having upward direction as positive. So downward man na atong duha ka 350 newtons, no? So minus 350 or negative 350 rather, minus 350 plus t. So this one is plus ty, no? The y component of this inclined t. So t is just ty is just equal to t times 3 over 5 minus AY, di ba? So, ato lang yung gamayan para mas maklaro ang operation. So, minus AY, since downward direction man si AY, okay? Equal na to 0 since wala na may lain y component nga force or force nga nag-act sa y-axis. Alright? So, solving for t, or not t rather, but ay, sorry, no? So, t is obtained, no? Na-solve na nato si t. So, substitute the value of t here, you will obtain also the value of ay. And ay is negative 383.584 newtons. Again, the negative sign there indicates that the correct direction of our AY is just opposite to the assumed direction of AY, which means AY is upward yang sakto nga reaction, no? So, nara siya. Next, how about si AX? So, if you will look at the figure class, no? we have three forces. Yeah, two applied loads and then two reactions or three reactions. T, then AX and AY. So sa y-axis class, so kaning duha ka 315 applied load, so wala na sila appeal, no? Kay naman na sila sa y-axis nag-act. So the only x-axis or the only force that is acting on the x-axis is si TX nato and also our AX. So silang duha. Okay? So summation of forces along x-axis you have here, summation of forces along x-axis is equal to 0, having rightward direction as positive. Ax is to the right, therefore positive, minus the tx. Note this is tx. So tx is just equal to t times 4 over 5. So you have there t times 4 over 5. So transposing this term to the right side of our on the right side of our equation. So this will give us a positive value, diba? So substituting the value of t to solve for ax therefore is 421.888 newtons. Okay? So since we have obtained a positive value for ax, that only indicates that correct ang atong assumption, no, sa direction ni ax. So as is lang si ax. Now, the total force. So of course, it's just equal to, so RA, no, the resultant force or the resultant reaction at A is just equal to square root of AY squared plus AX squared. Therefore, the total reaction at A is 570.198 newtons. Okay, and this is now our final answer for this last question sa ato ang quiz. So any questions or clarifications?
Sir, kato ba itong sa B bitaw, sir, nga moment?
Yes, asa nga problem kani
Sa taas pa, sir.
kani siya.
Itong, kung ito, sir, B,
Kani.
sir, yes, sir.
Mm.
Nag-question, sir, ba na, dili ba na siya i-change to force ang kanang moment, sir, kay para magamit siya na ang katong force na ng B kay magamit siya.
Okay. So, dili na ayon na i-complicate imong life. Kaya yatag naman siya as applied moment at point B. So, consider it as a moment. Okay?
Okay, sir. So,
Mm,
dili na kailangan i-gamit ang force tapos magkuha pa kag
yes.
RF, BX or BY, dili na. So,
Oo, dili na.
okay, sir.
Okay, so another clarification. So, thank you for that, no, clarification at least. Naklaro sa imong end. So, wala na yung questions? So I hope naka-follow, no? Absorb ra siya hinay-hinay. Anyway, I'll be uploading this solution manual on UseTapManPod for you to have for you to have a reference also, no? Pag mag-review mo para sa atong upcoming midterm examination. Okay? So before we proceed, no, with our next agenda for this session, no? So at this juncture, mura lang og kuan ba event. At this juncture, let us have a coffee break lang muna, no, for a while. So time is 2:37. So siguro 40, 50, mga 2:55, no? We will resume at 2:55 p.m. Okay? So for now, mag-break lang sa takadali class, no, para pahulay po tagamay. So by 2:55 mag-resume ta sa to ang lecture. Although gamay na lang man kaayo siya nga part. So dali na lang ta mahuman. Mga less than 30 minutes na lang siguro din natong lecture. So basically by 3:30 siguro mag-end na to ang session. Okay? So for the meantime, let's just have a break. No? So bye for now. Ang say brand sa akong kape. Um, Kuan ni siya, sagol-sagol man ni. But for now, kay napalit ra ko sa cafeteria. Ingon ani siya, bitaw. No eh, mga pisa ta class. Bye for now. So, murag nanubra man ang snack, no? Anyway, let's just go back na to our discussion. So, let's just continue our discussion. So, by the way, no, we are now in week 8 of our course syllabus. So, week 8 na ta karon, and this is the last session that we will be having before our midterm examination. Yeah, midterm examination. So, by next week class, since our midterm exam is scheduled on November 7 pa man, di ba? So, basically next week, dili ta mag-meet since kana nga week is midterm week man na siya. So, wala tay klase mahitabuan na. So, use that time to prepare for your midterm exam ng mga schedules, no? So, not only sa statics, but also sa other ninyo nga mga subjects or courses. So, sige no, to continue. So, this is now the last part no, of our discussion on equilibrium of force systems. So, just a recap, no? When we say static of equilibrium, no, the structure is in static equilibrium if the resultant force and resultant moment are both equal to zero. Okay? So, we can say nga in static equilibrium ang state ng sa imong object if walay resultant force nga nag-act sa system. Okay? Because the effect of that resultant force man could class, no, if ever na a resultant force will tend to translate, no, or will tend to move your object. Okay? So, tendency is there will be translation. No, it will cause motion sa imong object. That is why static equilibrium nga condition or nga state sa imong object, the resultant force must be equal to zero. So these are the equations for equilibrium or equations of equilibrium. So under aning summation of forces is equal to zero. So we can also say that summation of forces along y-axis is equal to zero, and summation of forces along x-axis is equal to zero. So basically, natay tulo ka equation class no for equilibrium. Then the third one is this one. The summation of moment is equal to zero. Okay? So these are the equations of equilibrium. Next is kaning basic loading and support. Actually, class kani siya nga topic no is they should be introduced to you during your mechanics of deformable bodies pa nga course or nga subject. However, since we will be dealing with supports and reaction and as well as combination of basic loading here in statics, might as well ako na lang siyang i-introduce sa inyo ha karon pa lang, no? So ako na siyang i-introduce sa inyo ha as early as now. So hopefully nga timan-an ninyo ni because mobalik pa na siya pag abot ninyo sa strength of materials and so on and so forth. Okay? So if maka-proceed mo next semester, no, if makapasar mo ani nga subject, then you may enroll to Mechanics of Deformable Bodies. So now, let's have this basic support and reaction. I know nga kaning roller and hinge, ako na siyang na-elaborate last time. No? Ako na siyang na-discuss sa inyo ha. So, as a recap lang, no? Roller support, no, ang iyahang not abbreviation, but representation rather, no? Or symbol is literal nga ligid. Okay? So, also, pwede po natin na siyang i-represent as this one. Okay? So, pwede po na siya ng symbol. So, we know that a roller support only has one reaction, and that is perpendicular to the surface. Okay, so klaro na ha. So, meaning if mag-incline ang imong roller support, so mo po na iyang convention or direction sa imong reaction. Okay? Then, hinge support or pin support, um, ina nila na iyang symbol, no? Or iyang representation. Okay? So, a hinge support can resist two action forces, no? So, makaresist na siya o vertical and horizontal na mga forces. That's why we have two reactions, no? For a hinge support. Now, I'd like to also emphasize no nga a roller support and a hinge support doesn't have doesn't have resistance to moment, 'di ba? So ako lang yun na siyang i-highlight. That is why we can say nga moment at hinge support and moment at roller support is just equal to zero. Okay? And then, mo po na yun natong basis na nga wherein maka-apply to or asa ta nga point pwede maka-apply og summation of moments. Okay? So, now, kaning third type of support class no kaning fixed support is ingon ani lang na siya oh. Okay, restrained kibali. So a fixed support has three reactions. Okay, and what are those? So you have vertical reaction, horizontal reaction, and moment. No? Moment reaction. So, your restrained or your fixed support class, no, naana siya resistance to moments. That is why you cannot say that summation of moment at restrained force, restrained or fixed support is equal to zero. No, you cannot directly say that one. Okay, so I hope timan-ana ninyo siya. So how about the basic loading? So sa basic loading class, no, wala ni mga applied na mga loads or forces. So basically na itulo ka classification. We have the first one, the concentrated load. So literal na concentrated. So concentrated at a certain point. No? Sometimes this is also referred to as pointed load. Okay? So mo ni siya klasa, concentrated or pointed load. So technically, kanang atong mga ginadeal na mga forces sa atong previous na mga problems no or sample problems, those are concentrated loads or pointed loads. Okay, ingon ani ra man ang itsura, di ba? The next one is uniformly distributed load. So for the uniformly distributed load, from the name itself, a uniform iyan distribution, no? So there is a magnitude of force, no, that is being distributed all throughout the span or at a span. Okay, so if this is the total length L, this is our uniformly distributed load. Now, question is, if mag-take tag moment, no, like for example, naa lugar kay reaction 1, natay beam lugar, no, for example, reaction 2, and then you have a uniformly distributed load acting at this region no, of your beam. So how do it solve for it? No? Kung mag-take tag moment at R2 or R1, solve mo na to na siya pag-solve. No? Kay naanad man ta nga, moment is equal to force times distance. 'Di ba? So with that, um, ato lang ni siyang i-convert into concentrated load. Okay? So ato lang ni siyang i-resolve into its equivalent na concentrated load. So how do we do that? So it's just the concentrated load, no converted concentrated load of this uniformly distributed load is just W times L. No, the magnitude of your um, distributed load multiplied by the span kung asa siya nag-act. No? So kung tanaw ni mo, di ba, mura mo siya rectangular. So with this, mura ra po siya area sa imong rectangle. Di ba? W times length. How about the location? Asa man na mag-act imong concentrated load? So of course, mag-act na siya at its centroid. So centroid sa imong uniformly distributed load. So we take the regular, the rectangular na shape, di ba, for uniformly distributed load. So we know that for a rectangle, asa man na nato malocate iyahang centroid, it's just at the center, no, L over 2 ni siya. Okay? So, L over 2. Dari na lang siguro ni ko isulat para mas maklaro. Okay, so that is L over 2. Muna iyang location. So, meaning, kung mag-take ka og a moment at R1 at R2, so kung i-convert na to na siya into its concentrated load, we know that this location is, di ba, L over 2. So, kung pila span ani, kung asa siya nag-act, then plus this distance here, muna na dato moment arm na for PW na force. Okay? So I hope that's clear. Next, how about the varying load? So varying load classes from that term no nagvary siya from one point to another. So let's say at this span na ay nag-act na varying load no so from minimum or from zero to maximum. So W being the maximum nga load. So nagvary siya 'di ba at every point. So if this is length, then that is W. So ang ato pong buhaton no is just ato na siyang i-convert into its concentrated load. So PW. So how do we do that? So PW is just equal to 1/2 of WL. Okay? So ana lang. L is wherein asa nag-acting imong varying load. Okay? How about its location? So recall from the basic no nga properties sa to ang geometric shapes sa centroid po na mag-act imuhang concentrated load class. So asa man ang centroid sa triangle no? So asa man na siya na locate? So it is the ring apart this is 1/3 of L. Then kani po siya na part is 2/3 of L. Okay? So, i-review na ninyo class ha. I hope nga wala pa na ninyo nalimtan. But if nalimtan na, i-review gina ninyo ko asa mga centroid sa mga basic ng mga shape. Okay? So, sige na, no? Let us apply this principle and concept to our sample problems para mas masabtan na to siya. So, kaning sample problem 1 and sample problem number 2 class is ako ni siyang gihatag sa inyo ha as assignment. So, if you notice siguro karon by now, naana siya na post sa USTEP. No? Actually, gi-post na ko siya kaganina. Ang inyong assignment number 3. No? So, your assignment number 3 is kaning sample problem number 1 and sample problem number 2. Okay? So, what you will be doing is handwritten solution siya, no? So, wala ta nagamit atong quiz nga function sa USTEP. So, i-upload ninyo ang inyong solution, no? Ang inyong handwritten solution. So, dili na necessary nga i-PDF pa ninyo siya, i-etc. pa ninyo siya, no? Pwede ra nga picturean ninyo inyong solution, then upload ninyo diretso ang picture sa USTEP. Since ga-accept man ang USTEP og mga JPEG, JPG, PNG nga mga files sa photos. Okay? So pwede ra po na siya nga style. But if gusto nga i-PDF, then you may do also. Pwede po nimo na buhaton. So it depends on you. So deadline for your assignment number 3 is actually tomorrow at 4 o'clock in the afternoon. So, one day lang akong gihatag ani class no since this is very easy and 2 items lang siya. So, um, this will also serve as your review, no? Kung unsaon ninyo pag-apply ang inyong nasabtan sa tuong discussion karon. So, this is equilibrium of parallel for system nga discussion. So, you might be wondering no nga nganong naghatag ko og assignment nga ang deadline sa tong PIT is this coming October 29, right? Karong Sabado na siya. So don't worry kay ang kanang inyong assignment number 3 dili na siya included sa inyong output sa midterm nga PIT. Okay? So if ever nga humana ka og buhat og PIT nimo, nag-submit na ka, so don't worry kay um dili na required no nga idugang pa nimo ang assignment number 3 sa imong PIT. So as is na to siya. Kay ang kaning assignment number 3 um dito na nato ni siya makitaan sa final term nga PIT. Okay? So kaning assignment number 3 ha dito na ni makitaan sa assignment na sa final term nga PIT. So wala ni siya ilabot sa inyong midterm nga output. So dili mabalaka kung naay nadugang nga quiz. I mean nga activity karon nga week, no? So I hope that's clear ha. So for the sample problem number 1, you'll have to draw this one, no? Iyahang situation, no? Ang iyahang free body diagram as well. So for situation 2, class basin nagworry mo nga ano maning nanay double layer, no? Nag second layer naman ni siya. Na may second floor ang figure. So, simple lang ni siya actually. Inyo lang na siyang i-separate no og analyze. So, i-cut ninyo na siya din ha. So, kung watan ta na siya og free body diagram here. The bodies is the roller and your reaction cream. So, this is our beam CD by the way, and then beam AB. So, this is R1, R2. Okay, then load ring P. So what you will be doing is analyze first, see um, beam CD. Okay, so analyze first beam CD. So how do we do that? So since this is a roller support here, no, so we can sum up moment here. So kung mag-moment na din so makuha na to ang R3. Okay? So grabe no, gigayda na gid ako sa pag-answer. So, and since this is a roller support, so we know na siya reaction in this manner, no? Perpendicular sa tong beam CD. So, makuha ninyo ang R3 first, no? Tayon, masolve po ninyo ang RC, no? Reaction here at roller at C. By the way, this is called internal roller, no? Or internal support. Okay? And then, if masolve na ninyo ang RC and R3, bali na po kang beams AB, no beam AB rather. So, aman ang iyahang load. So, take note na kanang roller, no, at C, nakapatong raman na siya kang beam AB, di ba? So, meaning that will serve as a load at beam AB. So, kung pili mo reaction at C, RC, mapunay mong load at beam AB. Okay? And then, masolve na yun ninyo si R1 and R2, no? Eventually, by applying the equations of equilibrium. So take note that these two beams are simply supported beam. So later, ako ni siyang i-discuss pod, no? Kung si pasabot, umingon taog, simply supported nga beam. Okay, so that's how you solve for this situation or for this sample problem number 2. No? In this case, your assignment number 3, question number 2. Okay, so I hope that's clear ha. So, naano ni siya sa USTEP, naka-post na ni. So, Diretso na tawid. Sample problem number 3. Wow. Mong Carl. Okay. So, going back to our discussion, no? Um, let's go directly no with sample problem number 3. So ako ni gituig ang sample problem number 3 class no para makita ninyo ang application sa to mga different basic nga mga loadings. Di ba we have or you can see here concentrated load, uniformly distributed load and as well as varying load. So naagi siya combination gid siya no sa tulo ka basic loading nga akong gi-introduce inyo earlier. Okay? So the problem here states that assuming a simply supported beam. Determine the reactions for the beam loaded as shown in the figure. So, easy na kayo ni class since reactions na nagipangita no, R1 and R2. So, kung may tawag simply supported beam class, no, pasabot niya ana is, at one end, it is supported by a hinge. No? Hinge support siya at one end. And then, at the other side po, or at the other end, supported by a roller. Okay, so hinge and roller nga supports. Okay, so muna pasabot ni simply supported beam. So, since niingon man siya no nga simply supported beam ang ato ang figure here, so it is also safe to assume nga kani siya is hinge, then this one is a roller. Okay, so R1 and R2 here are the vertical reactions no of our hinge and roller respectively. But we know man nga at roller isa lang iyang reaction. So R2 is as is. And then sa hinge is, di ba, we know nga diha naman na siya duha ka reaction. So meaning we'd expect nga napod ni siya horizontal nga reaction diri nga part. So if this is point A and then this is point B, so pwede nato siyang pangalan as AX and then R1 is AY, di ba? Then R2 is pwede na siyang pangalan as BY. Okay? So if you notice class na ang applied loads no or applied forces sa to ang structure are acting directly along y-axis. Di ba na lang sila sa y-axis tanan? Kay downward mo na tanan. Wala man ta kakitag incline dira. Wala po ta kakitag force nga nag-act along x-axis. Okay? So, if naman ko incline force class, tendency is, pwede na to na siyang i-resolve into x and y components and therefore we can say nga na force nga nag-act sa x-axis. So, in this case, wala. That is why, if ato na siyang applyan of equation of equilibrium, summation of forces along x-axis is equal to 0. So, ax is to the right man. So, assumption na ko is the rightward direction, no? So, ax is just equal to 0 since wala na may lain, no? So, walay gina-resist nga force sa horizontal, no? Walay horizontal nga reaction. Okay? Now, how about AY and also BY? So, kung mag-sum up the forces on y-axis equal to 0, we have two unknowns, no? AY and BY. We don't know them. That is why, kung kanya itong gamiton, maglisod pa to og identify no or compute directly for AY and BY. Which means, let us proceed no with the third equation of equilibrium. And that is the summation of moment equal to 0. So, asa man ta mag-take of moment? So, of course, I have mentioned diba, hinge and roller supports doesn't have reactions or resistance to moment. That is why we can take moment at these points, no? At roller support and at hinge support. So, depende sa inyo ha. For this case, mas convenient kung kang point B ta mag-take of moment, no? So, by summation of moment at point B equal to 0, since that is a roller support, having counterclockwise as positive. So, let us have this one, no? So, meaning, At point B class, nag-take man tag moment then ha, R2 will be eliminated, right? Since it is acting directly at point B. So, ma-eliminate lang na siya sa tong analysis and that leaves us with R1 na lang ang unknown variable. Okay? So, as mentioned ako earlier, di ba, what we will be doing is i-convert nato siya into its equivalent concentrated load. Okay? So, this uniformly distributed load, ato lang na siya i-convert into a concentrated load. So if ato lang siya panganlan nga force P, and then also this varying load ato lang na siya i-convert into its equivalent nga concentrated load. Pangalan lang nako sa siya as F. Okay? So now, pila may magnitude aning ato ang equivalent nga mga concentrated loads. So P di ba is just equal to for uniformly distributed load WL. So magnitude is 6 kilonewton per meter times the length, no? The span kung asa siya nag-act imong distributed load class. So 3 meters lang, right? So 6 times 3, that is 18. So 18 kilonewtons. 'Di ba? Kay 6 is kilonewton per meter and then 3 is in terms of meters, so cancel out ang meters. The resulting unit is in kilonewtons. So how about si F? So F is just equal to 1 half WL. So substituting, you have 1 half times W, maximum nato na load is 15 times the span, no? Kung asa siya nag-act. 3 meters lang gihapon. So, how much man is F? So, F therefore is 15 times 3 is 45 divided by 2, that is 22.5 kilonewtons also. Okay? So, na tayo mga equivalent nga distributed, no, not distributed but concentrated loads. So, next is, let us also establish its distances para mas dali na to siya ma-locate. No? So, kani siya, no? Kaning sa uniformly distributed load class, we just know nga L over 2 lang man na siya, di ba, ang centroid. So, this is 3 over 2 and 3 over 2 or 1.5. So, for this case, sa triangle, this is 1/3 of 3 and 2/3 of 3. Okay? So, we now have these distances no, or locations of our equivalent na mga concentrated loads. So, we are now ready to compute for um, the moment at B. So, by taking moment at point B, so akong walang unahon class no is from farthest na force and then paduol lang paduol. So, kibali ana ang akong style kay para mas ma-cover yun siya tanan. Walay makaligtaan. So, R1 will create unsa nga rotation um, with respect to point B. That is clockwise rotation, di ba? So, counterclockwise is positive man akong assumption. So, this is negative R1 multiplied by its moment arm. Pila man ang moment arm? You have 1.5 plus 3 plus 3. So, that is 7.5. Okay, this is not 75, 7.5. How about this concentrated load na 12 kilonewtons? So 12 kilonewtons with respect to point B will rotate counterclockwise, therefore plus. No? So plus 12 times distance is 6 meters. Then kaning equivalent na distributed na the equivalent concentrated load na of this distributed nga uniformly distributed load is 18 kilonewtons and that will tend to rotate counterclockwise as well. So plus 18 times distance, moment arm niya is 3 plus 1.5. So 4.5. Diba? So 3 over 2 is, that is just 1.5. So 1.5 plus 3 class is 4.5. Last is kaning ato ang varying load, no? So yung equivalent na Concentrated load is 22.5 and that is counterclockwise na rotation with respect to point B, therefore positive no or plus ang operation. So 22.5 times 1 meter. So 1 meter is kani siya diri nakuha no. Ako na lang siya isulat class. 1/3 of 3. So 3 over 3 is just 1, di ba? So equal now to 0 since wala na may lain na force. So in this equation, isa lang atong unknown variable. So if ibalik nato ning term nga negative R1 multiplied by 7.5 to the right side of our equation, so mag-positive na siya, no? So positive value na siya. So pila man ni ato ang um, R1. Excuse me. We have here 23.4 kilonewtons. So positive ato nakuha na value, therefore it indicates na correct ato ang direction or assumed direction nato with R1. Okay? So that's it, no? R1 is 23.4 kilonewtons. Diba I have mentioned earlier na kung mag-summation of forces ta along y-axis, we have two unknowns, R1 and R2. That is why we cannot utilize it earlier yet since two unknowns pa man ta. However, this time, since na-obtain naman natong R1, so kung mag-summation to of forces along y-axis, isa na lang atong unknown variable, which is si R2. Diba? So with that, pwede nato ma-solve or makuha nato ang R2 no, by summation of forces summation of forces along y-axis equal to 0 no, by applying this equation of equilibrium. So what are the forces on y-axis? You have R1, right? R1 is upward, so positive. Minus 12, since downward direction as 12. Minus also 18, no? The equivalent na concentrated load of uniformly distributed load. Minus 22.5 plus R2 equal na to 0. No, positive R2 since upward yung direction. Substitute the value for R1, therefore, ma-obtain na to si R2. So, how much is this one? This is 29.1 kilonewtons. Okay? So, R2 is 29.1 kilonewtons. Okay? So, that's it, class. So, mula ang ipangita man sa problem, di ba? The reactions at both ends. So R1 therefore is 23.4 and R2 is 29.1 kilonewtons. Okay? So I hope nasabtan class ha. So any questions or clarifications?
Hanggang so far, sir.
Okay, so I hope nga naka-follow class ha. Nasabtan na to ang principal ani. So if wala questions sa atong discussion, no, I'll be uploading this lecture material on USTEP. And that ends our discussion on equilibrium of force systems class, specifically on parallel force systems. So, before we will dismiss, no, before tamo i-dismiss, will ako sa ning i-announce, no. Although I know nga kabalo na mo sa tong schedule sa to ang midterm examination. So it is scheduled on November 7, 2022 at 11:15 a.m. to 2:15 p.m. So no lunch break ni siya, no? So continuous ni siya. So if I were you, maniud to na mo daan ha. So paniud to na mo daan before mo mag take sa exam. Also, since this is section 2U, no? So section 2U is naamo na butang sa engineering complex, no? 6th floor. So sapat ang inyong venue for the exam. So I hope katod na mo aning 6th floor too. So exam type is objective type and problem solving. So kanang objective type class mara kuan lang na siya, pasabot lang na siya kana bitang mga identification, multiple choice, kanang true or false, mga ingon na nga type of exam. Okay, so expect nga natay mga ingon na nga type since included man siya sa ato ang exam.